Hello everyone. For those who don't know me, I'm Katerina. I'm part of the sales team here in Recutech. Today I'm gonna to show you two presentations. We will start with the first one. We will discuss how to choose the best heat exchanger from the technical point of view. We will talk about NEP, net energy performance, how we can calculate the net energy performance, and how we can use it in the real applications. Maybe when you are designing a new range of your units, you already asked yourself, did I choose really best heat exchanger I can for my application? Is the heat exchanger with the highest efficiency always the best choice we can have? Or is it better to have not that efficient heat exchanger, but with more reasonable pressure drop? After this presentation, I think we will be able to find the right answer for these questions. So what is the net energy performance? Net energy performance, it's a difference between two energies. Energy we get from the recuperation process, the energy which is recovered by the heat exchanger, and the energy consumption of the fans which we need to overcome the pressure drop of the heat exchanger. Mathematically, we could write it like that. So it's difference between two energies. And now we will shortly look at the calculation formula. We will calculate the first part, so the energy which we get from the recuperation process. We are calculating with VR. It's a constant 1.2 for air density, which is normally used for these kind of calculations. You know well, I think. Then, of course, standard pressure drop. It's a very important value in this calculation. We are calculating in cubic meters per second. Then we have a constant 1005, the specific heat capacity of air. And that's the amount of energy we need to heat up 1 kilo of air by 1 degree Kelvin or Celsius, doesn't matter. And then we have delta T, that's how much the exchanger is efficient. Its temperature increased at the inlet side by passing the air through the recuperator. If we are multiplying all these values, we will get the energy which we get from the recuperation process. Now we will calculate the second part, the energy which we have to put to the fans so they can be able to overcome the pressure drop. We have two fans, so it's twice 2 multiply again standard airflow in cubic meters per second. And then a very important value, standard pressure drop. And then we have two constants. One, 60% we calculate as an average fan efficiency. Okay, sorry. It's the constant which is mostly common in this kind of calculations and kind of applications. And then we have constant 2.5, that's a primary energy factor for obtaining electricity. Maybe you know this number from other similar calculations which you do when you are designing new units. So that's the second part of the formula. I prepared an example here. We will calculate what's the net energy performance for Rec Plus 27 400. As you can see from the formula, you get 2747 watts and you have to put 185 watts. So the difference between these two values is 2562 watts. That's the net energy performance of this unit. What does this number tell us? We don't have any idea if it's high enough or if it should be better or lower. For that, we would need some comparison table which will show us the ideal range for the airflows we are calculating with and for the sizes of the heat exchangers. That will be a little bit too complicated. That's why we don't use it that much, the net energy performance value as an absolute number. But we are calculating what we call net energy performance ratio. We are comparing these energies, both energies, together. So the energy which we get from the process with the energy we have to put to the fence. We have 4 different ranges where we can move with the results. The worst case will be if the net energy performance will be lower than 5. It means that the heat exchanger is too small, has a very high pressure drop. The fans are running on maximum, and they still can't get over the heat exchanger. So it's not a good case. Definitely we should make a new calculation, better one. We could move to the interval from 5 to 9, where the heat exchanger still will be a little bit undersized, not that much as in the first case. It still has a slightly higher pressure drop, and the fans have a slightly higher power consumption, not that much as in the first case, but it's still not the optimal choice. The optimal choice will be when we will move from 9 to 18. This means that we have a very good ratio between the costs and the performance of the unit. The higher the better within this interval. If we are higher than 18, that means that the fan and heat exchanger are oversized for the air volume we are calculating with. The heat exchanger has a very low pressure drop, not necessarily needed. That's why it's not optimal. So I prepared another example here. Let's say that we are looking for a heat exchanger for 500 cubic meters, and we are considering 3 options: REC plus 17,300, REC plus 27,400, and REC plus 39. In the first case, net energy performance ratio is only 381. That's very low. You can see we have very high pressure drop, almost over 550 pascals. Definitely it's not the right calculation. This exchanger for this air volume we can't consider. In the last case, REC plus 39,400, we see we have very nice number of efficiency. We also have very low pressure drop. So why is it not optimal? The net energy performance ratio is over 25. It's quite far away from the interval in which we said it's optimal, so from 9 to 18. Even these values are that nice, doesn't mean that it must be the best choice. For the air volume of 500 cubic meters, we don't need that high, that big heat exchanger. It's not necessary. It would be too expensive. That's why the best option for this calculation will be REC plus 27,400. We see that we are within the interval for optimal choice. We have 1488, so let's say in the middle. We still have nice efficiency, almost 82%, and reasonable pressure drop of 160 pascals. Of course, we don't expect that you will calculate all these values by hand. That's why we have integrated these calculations into new version of AirSelect. You will find both values there, the net energy performance value as an absolute number, and also the net energy performance ratio together with the emoticon and with the short description, which will tell you if the choice you did was good or not and why. So we hope that for your future calculation this will help you, and you will use it, and from the first sight you will have the information if the heat exchanger you have is good or not, and you can also compare 2 heat exchangers together. You can compare what's the net energy performance ratio. so you will get the answer why the heat exchanger is good or not. So thank you for your attention. I hope I explained it well, and I'm looking forward to your questions in a few minutes. Thank you.